Hello, everyone. Today we're covering the final section of light, which focuses on color. Okay, this should not be a long presentation. Okay, so when you talk about color, how you get different combinations of colors, you get different combinations of colors by combining different ones together, right? Now, how you combine them with light and how you combine them with pigments or dyes or paints is different. They get their colors in a different fashion. Okay, so for example, the colors that you see of objects, okay, of your phone, your desk, whatever, the color that you see is the color that is reflected, okay? The rest of them are absorbed, okay? So, for example, sunlight is pure white light, right? Okay, so you have white light, pure white light traveling around. When it strikes something, some of that light gets absorbed. The piece that is not absorbed is what you see. Okay, so for example, in this case, we have a leaf. Leaves are green typically. Why are they green? They're green because they absorb everything else except green. Okay, it's not always one color that's reflected. So, for example, things that are like cyan or teal or like these different shades, that's when they reflect a combination of two or more and you get a new color. But for the most part, what you see has to do with what's reflected. Everything else is absorbed. Okay, that's how pigments work. But light is a combination of everything. So if you have, for example, let's think about like a laser. Okay, you can have different colored lasers, right? So when you have a laser and it's a specific color, that's because the laser is producing one specific wavelength. Okay, you can design lights that produce only one type of wavelength. If you remember, these lights, okay, these lights each have their own specific wavelength. So if you design something to only make one of them, then you'll get a pure color, okay, without having to use a filter, okay. But the reason I'm bringing this up is because I need you to understand these two concepts of color addition. Okay, there's color addition and then there's color subtraction. Okay, and we'll get into that difference now. Okay, so let's say we have some let's flashlights. Okay, we have some flashlights. We have a red flashlight, we have a blue flashlight, and we have a green flashlight. Each flashlight is only making one pure color. Okay, so the red flashlight is making wavelengths of only red light. Okay, it's not like pure white light where you have all of them together. Okay, it's only making one specific color of red light. Okay, if we wanted to make a new color with these flashlights, you would just stack them on top of each other. But the colors that you get, it's not necessarily going to follow what you might understand from pigments, okay? So for example, red and green make yellow, okay? With light, it's simple. You combine red and you combine the green light and you will get a yellow light. Simple, okay? If you combine blue and you combine red, you'll get a magenta or a violet, whatever you want to call it, okay? That's what you'll get. You're just adding the colors together. You are adding or combining these individual wavelengths together, okay? That's how light addition works. You are working with individual wavelengths. That's color addition. And that's how your TVs work, okay? TVs have these pixels, these LEDs inside of them that can switch between red, green, and blue. And some of them have a fourth one yellow, but most of them follow the RGB, okay? RGB stands for red, green, and blue, okay? That's how most colors work, okay? Red, green, and blue pixels. And they combine them to make whatever color needs to be on the screen, okay? That's how lights work. Pigments, it's a little different. Pigments work by subtracting colors, okay? Remember we talked about the leaf? The leaf appears to be green because it's absorbing every single color except green. Well, pigments are physical things, okay? You can touch them, okay? So they're like objects that absorb colors, Okay, so when you see a red dye, it's red because it's absorbing every single color except red. So now let's go back to the idea. We want to make yellow again. We want to combine red and we want to combine green. Okay, this is where it starts to get confusing because red appears to be red because it absorbs everything except red. Green appears to be green because it absorbs everything except green. So if you combine them together, now you have a new concoction that absorbs each other, okay? Because the red absorbs the green and the green absorbs the red. So you're not necessarily going to get this pure yellow that you expect, okay? Because yellow gets absorbed. Red is red because it doesn't reflect yellow. There is no yellow, okay? There is no yellow and green, there is no yellow and red. They absorb yellow, okay? The pigments work a little different. They work by subtracting colors, okay? So that's why it's hard, okay? It isn't perfect. Okay, it isn't perfect. So pigments are different. Okay, so I know here it says yellow is a combination of red and green. So if you get a yellow pigment, if you manage to make one, which you can, it's just not clear cut. What yellow reflects is both red and green. When you get a combination of colors, it's because they're reflecting both. So when we talked about the light, let's go back to color addition with the light. Okay, if you stack red light and you stack green light, you get yellow light. So if you want to make a yellow pigment, what you need to do is make a pigment that absorbs all colors except red and green. It needs to reflect the red and green so that the red and green can combine to make yellow light. Okay? So at the end of the day, it all goes back to light. But pigments work a little differently. Okay, they work by subtracting colors, not adding colors. When you're working with light, you have one wavelength, and you can combine those wavelengths however you want. Okay, that's how light works. That's that, and in that case, it makes it easier. Okay, it makes it easier. It's easier to combine light because you're working with individual wavelengths. But with pigments, pigments absorb everything except what's shown. That's what makes it difficult, okay? Because red pigment absorbs yellow, and green pigment also absorbs yellow and blue and red. Okay, so when you combine them together, now you just have something that they absorb each other. Okay, so you're gonna get this weird color. So like the ratios of things that you need, it's not clear cut and dry. Okay. Another thing, when you combine all light together, when you combine all the different colors of light, you get white light because white light is originally all the colors combined anyway, okay? But with pigments, because pigments work by absorption, if you combine every single pigment color together, you end up getting black because you end up making something that absorbs all colors. So that's the difference between pigments and dyes and paints and light, okay? And that's how you get your different color combinations. Okay, so these work by color subtraction, and light works by color addition. Okay, they call it color addition because you're adding individual wavelengths together. Like if I wanted to combine red and blue, I end up getting violet, so on and so forth. Okay, but with pigments, it's different because you're not working with individual wavelengths. Okay, they're absorbing everything together. Okay, so it gets a little complicated. If you were to combine red and green, you would get a yellow pigment, but it might be darker than you anticipate because it's absorbing a lot of color. Okay, so it'll just be like a dark yellow. Okay, it won't be bright and vibrant like you expect. Okay, so that's color addition and that's color subtraction. Okay, next thing I want to discuss real quick is this thing called polarization. Okay, I'm sure you guys have heard of polarizing sunglasses. What it means to polarize something is to get everything in the same direction. Okay. If you remember from the electromagnetic wave unit, light, they're EM waves. And these EM waves can travel in different directions. Okay. So when you put a polarizing filter, what the filter does is that it makes it so that only waves traveling in a specific direction can go through. Okay. So say here we have a tube and that tube has light coming through it. The waves travel in all different directions. That's why you have the arrows going all over the place. But if you put a polarizing filter on it, you can make it so that only waves in one direction can come out. So for example, you can make it so that only the waves traveling vertically up and down can go through, okay? And that blocks a lot of the light, and that's how you protect your eyes with polarizing sunglasses, okay? That's how they work. That's all polarization is. There's also natural polarization. So for example, when light hits a mirror, it has to bounce off the mirror. And the only reason you see an image is because it bounces into your eye, right? So when light hits this mirror, light comes in from all these different angles, but only one angle works for hitting your eye. So in that case, mirrors act as natural polarizers because there's only one angle, there's only one direction they can hit the mirror at that would make it to your eye. Okay, so that's what they mean by natural polarization. So again, all polarization is just a filter that makes it so that the wavelength has to be traveling in a specific direction in order for it to make it through. And that's just one way to filter and block out light. Okay, that's polarization. All right, so that's your colors, that's your polarization, and that's it for this section. Okay, remember you have color addition and you have color subtraction. Color addition focuses on individual wavelengths of light that you could combine together to make new ones. And color subtraction works by figuring out absorption patterns. Okay, if you want to make a specific color, you need to make it so that it reflects specific colors. Okay, so it's a little more difficult and more challenging. Okay, that's it for today. As far as work is concerned, then 12 minutes. Okay, not bad. As far as work is concerned, just a brief little study guide that focuses on the color addition and subtraction techniques. Okay, so the questions all focus on what you need to do in order to get a specific color. Okay, so for example, number 1, part A, it says, it is common knowledge that chlorophyll allows green plants to use light for photosynthesis. Okay, chlorophyll is the thing inside the plant that absorbs the light to make it do what it needs to do to make energy. Okay, so it's asking which colors of the visible spectrum do the green plants absorb? Well, if the plant is green, it must be absorbing what? Because if it's green, it's because green is reaching our eye, which means what else is not reaching our eye? Okay, that's how that works. Part B, you have a greenhouse. A greenhouse is a place where you can grow plants. Okay, that's what a greenhouse is for in simple terms. It's just a place where you can grow plants. A window has broken in this greenhouse. You need to seal the hole, but you can only seal the hole with either green plastic or red plastic. Which one are you going to use? And you need to explain which one you would use. And let me give you let me help you out here. Basically, I'm gonna explain the answer here. Plants need sunlight in order to make their energy. Most plant leaves are green, which means what color don't they absorb? They don't absorb green, which means if you put a green filter on it, that means the only light that's going to come in is green, which means the plant won't absorb it and they won't make energy. So based off of that, what color should it be out of your two options? I'll leave it at that. And then number 2, in the different parts, basically they're essentially asking you what colors are you going to make when you combine X, Y, and Z. Okay. If you combine this and that, what are you going to get? So on and so forth. Okay. That's how this works. And you have to be able to understand color addition versus color subtraction. Because number 2, you have pigments and you have light. And now you're going to combine the ideas and see what you get. Okay. But that's it for today. Thank you very much for your time. I hope you are all staying safe. Take care. God bless. Enjoy the rest of your day.